Without further ado, it gives me great pleasure once again to inform how we can all delve into how AI is fundamentally transforming our economy and society. At the heart of this transformation are the intelligent, autonomous system, the repertoire of possibilities from self-driving cars to industrial robots, which is increasingly rapid. What does this mean for our future, our economy, and how should autonomous system be built to maximize human potential? Well, here once again will be our distinguished panel to talk more about that. I'd like to firstly welcome our moderator, Jonathan Weber, Global Industry Editor for Technology from Reuters News. Can we give him a big warm welcome, please? Jonathan, good afternoon, sir. Have the same applause and enthusiasm for Professor Hiroaki Kitano, President and Chief Executive Officer of Sony Computer Science Laboratories Incorporated. Professor Hiroaki, welcome. Dr. Ben Goertzel, Chief Executive Officer, SingularityNET, and Chief Scientist from Hanson Robotics. Dr. Ben, good afternoon. Luis Gonzales, Manufacturing and Industrial Lead and ASEAN Principal Director, Element AI. Luis, thank you for joining us. Vinay Jammu, Vice President, Software and Analytics, GE Global Research Center. Let's all give them a big warm welcome, please. Jonathan, hand the proceedings over to you.
Thank you very much. It's a pleasure to be here. Great topic and great panel we have here today. So to start out, autonomous systems, I think most people most often think autonomous driving, self-driving cars. And one thing that I've certainly observed as a journalist over the last 6 months especially is that a lot of the kind of predictions about autonomous cars and how quickly they'd be here seem to be fading a little bit. It gets a little bit more distant. Most of the trials that are out there seem unimpressive on a certain level. So I'd like to ask the panel, what do you think is really the timeline for when we're going to have self-driving cars?
Yeah, okay. I think like we are looking at the quite a number of autonomous driving, test driving at this moment, and some of the limited area, kind of feasibility study or proof of concept commercial service, and I think like we're able to have like a limited zone restricted autonomous driving service relatively quickly. But for the unrestricted autonomous driving, we are probably years away. I think we have a lot of problem to be solved, not just technology, but like all the social infrastructure and then the service model as well.
Yeah, well, and I think even honestly, even the limited zone stuff, like what Google is doing in Arizona, it's not. It's a long way from really being a commercial service, right?
I would say, we're not going to have unlimited autonomous self-driving cars on the roads within the next couple years. Within 5 to 10 years, I think we certainly will, and it will be rolled out incrementally. I would say something I've been thinking a lot recently is, as technology advances exponentially, people's impatience advances exponentially with an even higher exponent. So we have something like, wow, we may be only like 8 to 10 years away from having completely autonomous cars dominating all the roads in the world, and then suddenly people are disappointed, like, oh, you mean it's not happening in only 2 years, right? But I mean, actually, we're pretty close. It's clear how to get to the end goal, and of course, people's lives are at stake, so just as with medical research, so there's going to be some step-by-step testing and refinement as we perfect things. But I mean, the fact that we're going to be there like within like a decade, within almost all of our lifetimes, is still pretty amazing. And we'll see how rapidly we progress through all the step-by-step stages we need to go through to get there.
I can't agree more with both of you. Autonomy is not only a matter of technology or the science behind it. It's definitely something to be talked about, accountability, for example. And you cannot build, or we should not build systems where there's no human accountability in things as important as human life. So it's not only a conversation as to whether in a pilot scenario or in a lab scenario, you can account full autonomy because that would be a very short time span. We could probably achieve that fairly quickly. But is the practicality of putting, imagine you guys are from Asia, putting a autonomous vehicle in Jakarta, and the complexity that would bring, what we call dynamic contextual intelligence, which is not intelligence that is defined by set parameters, but that changes depending on the perception of the person, or in this case, the intelligent being in the driver's seat. So from the perspective of how practical this could be and how do you solve the accountability aspect of driving in roads where you can kill people, it's very important that we don't fancy the idea of full autonomy.
So I wanted to add, I agree with them. I think the complexity associated with the scenarios you see on the road are significant, the trillions of combination. So the way I crystallize for myself is an autonomous car is definitely killing a human being, okay? Now,
It's already happened.
yeah, it's already happened. So the question is, are you going to launch autonomous cars? There's a lot of thought goes into it. Now I add the second point. Human driver kills 10x that, 100x that. So which is better? So we are now discovering humans, which are quite bad, to hopefully computers, which will be much better. What is good enough in this numerous trillions of combinations of stuff that happens on the road? That is the discovery we are going through market testing. As Luis was pointing out, what's the accountability here? How good is good enough for it to become at scale? And today, for example, some of the examples I can give is there'll be niche segments where this will get launched. Trucks probably is closer. The work we are doing in GE is in locomotives. So today we have autonomous locomotives. Locomotives still go on tracks, a lot more clearer, but still there are all kinds of stuff that come in. But a decade ago, we introduced a technology called Trip Optimizer, where the locomotive automatically drives itself through the terrains, different terrains to different signals and so on, looking to optimize speed and fuel efficiency. And that's already happened a decade ago, and that's already in the market today. So there will be niche segments as autonomous vehicles start coming in, where first adopters will come in, where definition of how much risk is there is a lot more clearer. Definition of accountability is probably more easier to do.
Yeah, well, I think, to your point, I mean, niche applications like mining trucks appears to be the first major application of sort of driving, not on a track. But I mean, you're all real optimists about this, but I mean, from my observation, I mean, we're 5 to 10 years out from limited application, and we're 30 years out from free range. I mean, that would be my postulate.
I think that's linear thinking. It's not exponential thinking. Ray Kurzweil will be ashamed of you.
Right now, like autonomous vehicle will be the minority if you hit the road. But like, I think one day if like autonomous vehicle is the majority, actually, then the human driver are gonna have a problem. And the human driver will not tolerate working with the autonomous vehicle because they have to strictly follow the driving regulations and all that. So like I think like at that time like it's really the tipping point. The human driver will no longer enjoy driving itself. Like they're gonna go out.
And I think the important question here is not necessarily autonomous vehicles, but intelligent vehicles. Now, if you think about it for a moment, an airplane today has enough artificial intelligence to take off, fly, and land by itself. So the role of the pilot in the cockpit is more of a flight optimizer. It thinks of things that degrade the turbine, things that degrade the plane. It thinks of the angle of takeoff to increase by percentage hours of operation, the lifespan of the actual plane. And those kinds of thinkings before weren't just possible at all. Now the pilot gets to optimize not only its flight, but the overall lifespan of the actual plane. So if we think of what we really should be getting excited about, is we should be getting excited about intelligent vehicles, vehicles that helps us navigate better traffic, helps us optimize our day, minimize our travel time, or optimize our travel time and sleep on them while certain things are happening, but not reducing the accountability that it means to be inside of a car.
So to move away for 1 second from cars and vehicles, I mean, are there other kinds of sort of autonomous machine applications that we should be thinking about that are actually maybe much more important than cars, that don't have to do with transportation, that have to do with other aspects of human endeavor that we're maybe missing?
I can start. One area that is very close to my heart is healthcare. We do a significant amount of work in healthcare. And today, in the developing region, which is Africa and Asia regions, 5.4 billion people live, and majority of them don't have access to healthcare. The question is, how can AI and autonomous systems help provide healthcare solutions to remote villages? And a particular story of work we are really doing that I'm very excited about is how you can use AI to do maternal and infant healthcare. So a lot of times what happens is pregnant women in remote villages have to travel 50 to 100 kilometers to get to a hospital. But they get into very complicated situations they don't know until it is too late. And when the childbirth time comes, either the mother or the baby dies. So worldwide, 300,000 women die every year because of maternal infant, during pregnancy. So the question is, how can AI help? Can AI help? We talk a lot about it. So one of the pieces of work we are actually piloting in Africa and some ASEAN countries is, can we embed artificial intelligence into an ultrasound handheld device, which can a midwife train for 5 to 10 days. They train in 5 to 10 days. They can take it to this remote sites. It's just a handheld cell phone size. You can go and start taking readings of babies and mothers' health. So are you trying to do, for example, is the baby underdeveloped or overdeveloped? Is the baby have the umbilical cord around it, so you have a breech problem? There's a baby upside down. So what we're doing is we're taking AI algorithms. We work on a technology called digital twin, as I was talking about. You build the digital twin of a womb, and you continuously learn on the handheld device to predict if this mother or the baby requires immediate attention in the first semester, second or third trimester, so that they can go to the hospital before it becomes an emergency situation. So that's an area providing healthcare to massive number of people where we do not have enough sonographers, enough skilled doctors. Build AI into these devices so you can save more people. Is an area, a lot of passion for us, and we work quite a bit in that area.
Thanks. Yeah.
Well, I think another area that the AI autonomous system can actually transform the field would be the scientific discovery, particularly in life science. I actually proposed and then promote a field of systems biology. It's like, before that, like molecular biology and talking about genes and the molecules and relatively in isolated conditions, and systems biology turned into more system-oriented thinking, and they got the massive data and the network of the biology. And then the question is, we got the more perspectives, like, things are too complicated and we are flooded by the data. So we come to the conclusion that, those biology is not for human. We have to have an AI system to make sense out of that. So I think they will come, we're gonna have like a scientific discovery by an AI system. Of course, that will support the human being for time being. I think if we can start having an AI discover the science by itself, it will do 24/7, discover new principle, and I think that would be the future of the science.
So autonomous research system.
Yes.
I like
Yeah,
that.
this is really this is a great panel to be on, because two of the things I'm most excited about have already been mentioned by other people, which is systems biology research to cure disease and extend life, and then medical AI to help the developing world. I mean, one of our largest, actually, at SingularityNET and Hanson Robotics, our largest development team is in Addis Ababa in Ethiopia. So I'm seeing the needs there all the time. So that frees me up to mention another application, which is also very exciting, which is humanoid service robots in home and in office, which is what we're working on at Hanson Robotics with the Sophia robot, which has become so well known, is a sort of spokes robot and showcase. But what we're working on now is production engineering and scaling up manufacture. So in a few years, we're going to have a huge number of Sophia-like robots, initially rolled out in an office setting and in shopping malls and in hospitals for elder care and in schools as teaching assistants, and then later on rolled out as homes, so that just as now everyone has a house, a phone, and a car, before long everyone will have one or more service robots going around helping them do what they need to do. And I think perhaps the most interesting thing of all these developments is the connectivity behind the scenes. So you have a medical device, you have a home service robot, you have a teacher robot, and an elder care robot, you have a automated lab equipment and research assistant, but all these in the cloud can be connected together and sharing data. And this is part of where the blockchain comes in, as we're doing in SingularityNET and cryptography and security, because you don't want nefarious forces to own all this data and use it against anyone, yet clearly connectivity and data sharing is that's both what the AI needs to become as smart as possible, along with more and more intelligent algorithms, and it's what's needed to provide the best possible services. So we're going to see cars, robots, and all these other devices get smarter and smarter and all network together, and it becomes a massive global cyborg. It becomes a global brain with human intelligence and digital intelligence all connected together in very complex ways. And we're building something none of us really understands what it's going to be, but I'm sure it's going to be interesting.
So if I could, you know, a number of the questions here, people, and this was true on the previous panel I noticed as well, a lot of the, I'm going to amalgamate sort of some of the questions here which have to do with the kind of the ethics of all of this and the, you know, ultimately kind of what do people want, right? So do people actually want to live in a house where they have a bunch of robots talking to each other and kind of making autonomous decisions on their behalf about different aspects of their lives? And do people A, want that, and B, you know, if that, as that robot singularity comes around, you know, what kinds of rules do we need around it?
And I won't speak about singularity. I mean, I think it's some really great points of conversation, but let me perhaps approach it from a different angle. Humanity, there's certain things that we do not want from AI, and we definitely need to be conscious about that. Full autonomy for the purpose of replacing humans at this stage shouldn't be our target. Our target should be first, let's get our AI right. We cannot code into AI compassion. We cannot code into AI dignity. There's a lot of things that are contextual intelligence that humans know how to do well, which we're nowhere near close to be able to do. The other thing is we are still figuring out data biases. We're still figuring out biased inferences. So what this means is that full autonomy in certain functions replacing human capability for decision making when it requires contextual intelligence shouldn't be something we will be working on right now. However, we should be working on autonomy that helps us to do things that are done better than humans without forgetting the accountability that that takes. So from my perspective, I think that humanity is really excited about AI, and sometimes we love the Terminator question because it excites us, but let's get more pragmatic about what AI really is about and how it can actually help humanity.
Well, I think full autonomy as such, it's a philosophical notion with no meaning. I mean, a human being doesn't have full autonomy, and I guess no system in the universe does. But I guess I probably disagree with some of the spirit of your comments, and I think one very important area of research is creating AIs that are at least as autonomous as human beings are, which is not really all that fully autonomous in the end. We're heavily programmed by culture and by everything we see and interact with. And another very important area of research is teaching AIs and robots to be compassionate and to understand human values. And indeed, this isn't something we fully understand at this moment, but it's something that we can research and explore. And we're doing that, for example, in using this Sophia robot as a meditation assistant, which serves the role the robot helps people to get into peaceful states of consciousness, but the robot is also learning all sorts of patterns that people are going through as they meditate and relax, and learning what pleases and displeases people. So I think we should be working on making AIs that are autonomous agents in the same somewhat limited sense that people are, and AIs that can understand and optimize their own source code. We should also be working on teaching AIs compassion and ethics, and we should also be working on narrow AIs carrying out quite limited and specific functions. Because if you did make an AI with full-on human-level intelligence and human compassion and so forth, does that AI really want to be operating your microwave all day? I mean, or driving your car in a highly reliable way? Probably not. That should be a narrow AI system that doesn't need that much general intelligence or reflective capability, but just does that thing. So there's going to be a lot of different AIs at different levels of generality and different levels of empathy and understanding. But I do fully believe, just as humans are not the most generally intelligent possible system, or the highest jumper, or the fastest runner, we're also far from the most empathic and compassionate possible system. And there's ample for evidence of that. There's a lot of evidence of that in human life all around us. But I mean, there is a lot of risk in the approach that I'm advocating, which is pursuing these many different directions at once. On the other hand, there's also a huge amount of potential reward. And I would say that being afraid of creating amazing new things that are just barely out of our grasp, being afraid of this is not how we got out of the cave. This is not how we got out of the tribe and the village. I mean, the fact that we're willing to take that risk is why we're different than all the other animals on the earth.
I mean, there's a lot of opinions. Just really quick, it's not necessarily an if-or. It's a walk, crawl, run scenario. And to be honest,
well, we're running. If you're crawling, you'll be left behind.
No, we're looking to make sure that what we design and build, we plan for its consequence. That's ethical. And I'm thinking with the engineering mindset of making things actually work, not necessarily with the visionary mindset. So I don't think we're talking about different things. I'm just focusing on how do I build a future so you can get there.
You know, if you actually try to train or learn the AI to learn our ethics or value system, do you think we're going to reach the common ground for because the people have a different value, different ethics, and does the AI actually illustrate the difference rather than the commonality? Where are you going to end up with?
Well, if you look at the worldview and ethics of people from 500 years ago, all of us today, with maybe very rare exceptions, are horribly unethical, evil creatures who should be burned in hell forever after we die. And I mean, also, we may be incomprehensible cyborgs walking around all day, staring at these devices and with weird things plugged into our ears and so forth. So I mean, human values have been a rapidly moving target, and of course, they're wildly diverse now if you travel around the globe. So do I think if we teach AIs and robots human values, they can operate within the broad scope of human values? Yeah, I think that. But will they agree with every human being's values? Certainly not, because the human values as a whole are not consistent and coherent. So it's more a matter of human values and machine values growing and evolving in a coupled way together. It's not like there is some static, fixed, consistent set of human values that you can just copy into the machine.
So, you know, one thing, that kind of common terminology that we've been using, we talk about teaching, teaching AI to do this or that, or teaching machines to do this or that. And to me, that reflects that AI has become synonymous with what's actually a subset of AI, which is machine learning. And is that really kind of the thing that we've got that will be the thing for a while now, machine learning, that's kind of what AI is? Or are there other approaches to AI that are kind of fundamentally different from that and don't really revolve around, teaching by running huge data sets, through the machine?
Well, I think a kind of excitement in the AI has come from a deep learning. So machine learning and deep learning, also a deep reinforcement learning, and those are the key. And before deep learning comes out, expert system, all that, we try to program it. We try to handle the rules. And then the rule we think is correct is not necessarily correct because we have implicit knowledge which is not explicitly written. And because whatever we write in form of the rule, and then we simply ignore the implicit knowledge, and that's the bottleneck of the AI. And that caused AI winter previously. And it's big change, wave of the AI boom right now. is the fact that we have like a deep learning, deep reinforcement learning, which able to train you the system by the big data over the repeated situations. Like that actually implicitly convolute what the people implicitly consider, or like world's knowledge that's not very explicitly described. I think like probably we might have like a different kind of technology in the future, but for time being, we can consider the machine learning is a core driving force of technology for the AI.
So I wanted to add a little bit different concept. Agreed. I think everybody gets confused with machine learning and AI. Everybody thinks machine learning is AI. And then you start having this question of, oh, do you do text mining? Do you do intent classification? What about knowledge graphs and knowledge theory? I said, what is that? And then people start saying, okay, maybe I don't know what I'm talking about. So an aspect of that we work in GE is something called digital twins. So in digital twin, what we're really trying to do is we build a digital replica of a physical asset, like a jet engine or an MR machine or a CT machine. But it's got both the domain knowledge, the physics of the equations and the process and the thermodynamics and so on built in, along with machine learning. Both are embedded in. And this digital twin continuously learns every day through multiple modalities. First modality is data, where machine learning applies. But when textual information comes, when a human being texts you something, can you learn from it? When an image comes, I have an inspection image of a jet engine part, can you automatically learn? The areas of research we're working on is, can digital twins learn from each other, like human beings learn from each other? So these multiple modalities of learning, which gives the context, knowledge graphs and things like that, is a much broader form of AI trying to contextualize, which I think Louis talked about, very, very important. When you define a machine learning problem narrowly, here are my inputs, here are our outputs, everybody looks at it and says, I can do that. But when you define that much more broadly with an outcome in mind and multiple scenarios and contexts in mind, things become a lot more complicated. And that's when you need other modalities of AI, either knowledge representation, reasoning, evolution, learning, and so on. We see that coming a lot more. And targeting that for specific applications, specific outcomes is another thing that we don't talk enough. We talk AI, AI, AI. AI is for an outcome. You're trying to improve something. Then it becomes clear, right? Then machine learning may not be the only way to do it.
I think that there's definitely, on the point that was made on the success we have today, it's all really narrow AI. It's all basically very guided learning, let's put it that way. And this kind of guided or controlled learning that we have today is prevalent not necessarily because that's what we've been able to drive, it's all because it's what we've been able to have success with, which, to be fair, an element or the first iteration of digital twin is exactly that. But what we really want to move to is what we call reinforcement learning, which is no longer direct and no longer just based on what humans can control, but eventually allow for the inferences to be somewhat autonomous, which comes from the data. And that's where we expect the systems to exceed the human capacity to create correlations, exceed the human capacity to do inferences. Now, to the point of Vinay, the twins learning from each other, it could be that paradigm of eventually getting to reinforcement learning and eventually start really believing on the potential of AI, which comes from unsupervised training or unsupervised learnings, which is what my friend here talks really about. But this is what we're talking the next 5, 10, and 50 years. That's what I meant.
Yeah, I mean, I think with all due respect, the dichotomy between deep learning and hand-coded expert systems is very much a straw man argument. Because, I mean, if you look through the history of AI, I mean, yeah, deep neural nets have been around since the 60s with multi-layer perceptrons, but you've had evolutionary learning since the early 1970s, which is not based on hand-coded rules. And you've had logic systems learning from experience rather than from hand-coded rule sets. So I think there's a lot of confusion between the mathematics and the words regarding AI. So you talk about machine learning. Okay, does that mean machines that are learning? Well then, yes, of course, all of AI is about machines that can learn, right? If by machine learning you mean supervised learning algorithms that get labeled data sets and have models trained on labeled data, then no, of course that's a very limited subset of AI. You talk about deep learning. Well, what do you mean by deep learning? Do you mean systems that recognize patterns among patterns among patterns among patterns with feed-forward and feedback dynamics? Okay, well, yeah, the world is hierarchically structured. In that sense, intelligence must be deep learning. Do you mean a neural network trained by back propagation with sub-symbolic knowledge representation? I mean, then that's a very narrow class of AI algorithm. Arguably, it's a souped-up nonlinear regression approach that will have limited capability at symbolic reasoning and abstraction, or at very least, it's not clear that that's capable of doing everything a human mind needs to do. So I think within the research community, there's differences of opinion, but there's also clarity on what these things mean, whereas in the general public, there's a lot of fuzziness between the technical meaning of deep learning and machine learning and what those words evoke. So I mean, my view is deep neural nets like we have now and supervised learning like we have now are very interesting and very valuable, but there's a lot of other AI algorithms that are going to play a valuable role, and it will be by further developing and interconnecting different AI systems following different types of algorithms that we're really going to progress toward general intelligence and more capable AI applications.
Right. That makes sense. And I think that the neural nets are mostly what I was referring to in terms of the core, like what most seems like that's what most current AI.
But again, neural networks is a very general space also, and sort of feed-forward neural nets trained by back propagation is a specific corner of neural nets. And there's a general problem here, which is translating from the technical world into common sense vocabulary. I mean,
right.
It's important to do, but you do lose a lot.
Right. Okay, so I wanted to, somebody in the audience put up a version of what's always a great question for technology topics, which what is the most overhyped thing in AI, and what is the most underhyped thing in AI and autonomous systems?
The most underhyped thing is probably something none of us have ever heard of, right? Because it's so underhyped.
Everything's so new right now. If you're trying to think of overhyped, I don't know if it's overhyped, but I always get very annoyed now by the Terminator question, because one of the things we haven't understood, and the general public I really wish they start.
Can you just elaborate on what you mean by the Terminator question?
Are they going to replace and kill humans?
Yeah.
Right. And everybody,
because it's obvious they will?
Well, because Hollywood works well, but it doesn't mean that is knowledge. The real thing I would want to leave everyone a message with is the virtuous cycle of intelligence. Even though it's not necessarily what we believe the future will be in 100 years or so, but what is in front of us as a society is making sure that machines makes us smarter, and make sure that our interaction with machines make the machines smarter. And that is something that is perhaps underhyped because no one talks about it, but it definitely should be the right narrative for how we approach AI. Because that approach of AI will yield a much better result for society. It will also relieve a little bit the misconceptions and allow for things like what Vinay was talking about in the healthcare to proliferate, at least in the narrative of voters and people that push the politicians to allow for these kinds of research and data access and legislation to be real.
Well, I think one underrepresented thing, which we're going to surface soon, is what I call the AI bullying. Like when people actually find out something is an AI, people start challenging it. For example, last month I got so one of the company I created, I decided to go autonomous vehicle taxi service training, commercial taxi service right in the middle of Tokyo. And what's interesting is as soon as people found out there's autonomous vehicle, people try to cut in and try to squeeze out. So like, AI system being bullied. And it's gonna be the serious problem, because like as soon as people find out the autonomous vehicle, autonomous system, not just a vehicle, people start challenging it. And that's gonna be a problem. Okay, then the overhype.
Kind of a social
Yeah, the social
backlash,
issues. Yeah, social
backlash,
issues. Yeah, backlash. I
underhyped.
mean, now people will make a joke, fun out of that, but it's gonna be the problem if we start having a more autonomous system in a society. And in the overhype one, I would say is like people equate from the goal of AI to be human level intelligence. And I think like, the industry practical sense, we want to have something specific area, but way better than a human being. And that's what we want to do. What we want investment goals, it's not going to be like an AI, which is going to be human-like, because we can just hire a human being.
So to give a more serious answer than I did before, I mean, I think right now it's starting to be generally recognized that deep neural nets, in the sense of multi-layer perceptron type networks trained with backprop, particularly trained in this supervised learning way, it's becoming clear these are not going to, on their own, solve all the world's problems. On the other hand, I think a bunch of other AI paradigms have a long history behind them, such as genetic programming and evolutionary learning, logic and automated theorem proving, artificial life, and this sort of self-organizing evolution on ecology systems. I think all of these things have a long history behind them and a lot of real stuff there, and are not getting enough attention now in the application world, even though they're well known like deep in the research community. So there's actually a lot of underhyped stuff out there that's in your AI textbooks, but is not being used in so many startups and industry projects at the moment.
I'm interested in this social backlash question, that people are going to kind of reject, just sort of viscerally reject machines that they think are too smart, kind of. You saw with the Google Assistant, which you can't really tell that it's not a person, and so now they're gonna do some things to make sure you can tell it's not a person. So there are a lot of social factors like that. I mean, is that something we have to consider in the design of AI systems?
Yeah, I think it will evolve. As the interaction happens, the game theory is, right, machine does something, human will do something else, just to play with it, all right? And some of the scenarios will not be very good scenarios. I think this will evolve. It will evolve. I think the focus is there are still so many problems today to solve, right? Greenhouse gas emissions continues to be the biggest challenge. There's so many people in the world who do not have good, adequate healthcare access, food access. So that is the problems we need to bring AI. How can data help? For example, food wastage, right? 30% of the food in many of the countries is going waste. Can you use AI and artificial intelligence to save this food so you can be reused? Water also same thing. So I saw many startups here who are looking at water wastage and how to do leakage prevention and using AI. So if you focus on the outcome, people will accept it because it's of value. If you make it a game, then I will play games with it. Some of them will not be pleasant. Especially it becomes physical, right? So when you're playing with a Google Assistant, it's on the cell phone and the computer. But if it becomes physical, as in a car, I will start squeezing the car, I start pulling in, and all kinds of stuff that we will do. So one of the things I always remind myself with what is AI for me is to make our lives better. The top problems, right? Better food, better water, better healthcare, and try to focus there. And people will automatically pull from there.
I think there's an interesting philosophical aspect to what you bring, which we've seen some research before on that, which is, if you think of the first industrial revolution, there was a lot of resentment towards the machines for being able to do physical tasks better than humans. And I don't think any one of us now resents a hammer for hitting harder than we can. But it requires evolution from humans to eventually get the fact that their self-worth is not based on what's being challenged. So I think we've reached a point where our self-worth as humanity is not our intelligence anymore. And that's exciting. I know it's exciting for him too, because the concept of post-intelligent society becomes a very attractive conversation piece, right? But at the end of the day, I do believe in a world where humans will start to evolve. Think of the Maslow pyramid, and we start evolving into more philosophical, more ethical-based questions, because our human intelligence is no longer a limiting factor for our capabilities. So that portion of our brain that we don't use, that 90% that's just sitting there sleeping because we watch TV, can be affected now in things that are more evolved, like arts and other aspects of human capability, that we don't touch because we spend this much time doing spreadsheets. So in my particular opinion, I think that yes, it will challenge humans. Yes, there will be a backlash, and it's absolutely growing pains necessary for civilization to evolve.
Yeah, I agree with that. I would say it's absolutely the case over the whole trajectory of the growth of civilization. Humans have gradually become more and more comfortable with both tools, machines, and sort of systems doing things that only human individuals used to do. The big difference now is the amount of radical change that's happening within a single human's lifetime, though. I mean, the evolution of better and better hammers, and then jackhammers and shovels to steam shovels took a long time. So each person only had to adapt to a little bit. Now, my grandfather, who's a very bright man, he's a physical chemist, he never wanted to get money from an ATM. He wanted to go to the bank and get it from a guy, because like, what if the machine doesn't give me my money? Then what do I do, right? And he just didn't adapt. So we're going to see a lot of that. So I think that like my youngest child now is 7 months old, right? I think his generation, they're not going to be too fussy about thinking machines interacting with them. I mean, of course, some products are better designed, and some are worse designed, and some will get on their nerves, and some they'll want to use. But that generation, rather, they're not going to be able to imagine, like, how the hell did you people live without thinking machines doing everything for you? But how most of the people on the planet who are my age will adapt, or say a 50-year-old subsistence farmer in Congo or somewhere, right? I mean, how our generation, who are not crazy tech geeks, will adapt is a little less certain. And there's going to be lots of ups and downs, especially because the older generation is still in control of a lot of the world's resources.
Still in charge, yeah. So I think the big takeaway there being that we have to kind of get over ourselves as being the smartest ones around, right? And then just kind of go with a new
That's
kind
how
of
we evolve,
environment where
right?
we have a different set of values about ourselves.
Our technology outpaces our ability to evolve as a species. That's why nuclear weapons are so dangerous, because we've reached a point that we can self-destruct without reaching the conscience as a society and as a species to not do it. Right?
Well, apparently we have. We haven't done
almost there. Yeah.
Okay, well, unfortunately we're out of time, but that's a great discussion. I really appreciate it. Thanks very much to the panel, and thanks for your interest.
Thank you, Jonathan. Thank you, Professor. Thank you, doctors, gentlemen.